Here's question 5. This is a stats question on hypothesis testing. You may have noticed in this question there's an awful lot of irrelevant information that you just don't need to answer the question. I'll come back to that later. First of all, let's have a look at part A. If you want to take a sample of boxes that represent the whole population, you don't really want to be taking your boxes all from the same crate. For example, the crate might have been dropped, and so all the eggs, or a lot more eggs than usual, may be cracked in all the boxes in that crate. So in order to be representative of the population, really you should sample boxes from lots of different crates. So as long as you've written something along those lines, you'll get 1 mark for that. Then for part B, we've got to do the hypothesis test. So let's figure out what information is useful here for this. Well, it's a sample of 60 boxes, and it's assumed that 98% of boxes have no cracked eggs. Okay, so I'll just write that down. So a sample of 60 boxes, and the probability a box has, well, let's say the probability a box has any cracked eggs is 0.02. Just doing 1 minus 0.98 there. Now in this question, so before we move on, this is a binomial distribution. The sample size is 60, and the probability of a box with any cracked eggs is 0.02. So if we look at what's happening here, in the manager's sample, he's not very happy because he's received 2 boxes with 1 cracked egg and 1 box with 3 cracked eggs. So 2 boxes of 1 cracked egg, or 1 box of 3 cracked eggs. Now you don't really need all that information. What you do need to know is that 3 of the boxes, so in the sample there were 3 boxes with cracked eggs. Okay. Now you would expect 60 times 0.02, which is 1.2 cracked eggs. In a sample of 60, you'd expect roughly 1 cracked egg. So this is why the manager isn't happy. He's got 3 boxes with cracked eggs. Okay, whereas you'd expect only roughly 1 box to contain any cracked eggs. So he thinks that possibly they are being too generous with their 98% prediction. So let's do the hypothesis test then. So our null hypothesis is what we would normally expect, so 0.02. The probability a box has no cracked eggs. The alternative hypothesis, well, it looks like we've got more cracked eggs than we would expect. We've got 3 boxes of cracked eggs compared with roughly 1. So we're checking to see if this is actually more than we would expect. So we want to find the probability of a box with, getting 3 or more cracked eggs. So remember, there's 3 boxes with cracked eggs. You want to work out the probability of that happening, or a more extreme value. So we've got to find the probability of 3 boxes or more with cracked eggs, And to do that, we're going to do this. So use your calculator, do the binomial distribution on your calculator, and you should get 0.8812 and so on. Make sure you use the binomial cumulative distribution here. So just make a note, use binomial CD for this. And then do 1 minus your answer, and that should give you 0.1187. Now in the question, let's just go back up here. It says a 10% significance level. Okay, so was our probability greater than 10% or less than 10%? Well, this is greater than 0.10, 10% significance level. So it's not that surprising. It's not that extreme of to get 3 boxes with cracked eggs. Okay, if it was less than 10%, then that would be significant. However, since this is more than 10%, we don't reject HO. So do not reject HO. And then you always need to write a sentence relating to the real life situation here. So there's insufficient evidence at the 10% significance level to support the manager's claim. The manager's claim. Okay, now just going back to the question, I just wanted to point out how much irrelevant information there is here. So if you look at this, we don't need to know this. We didn't need to know that. We didn't need to know how many cracked eggs there were in each box, just that the box had at least 1 cracked egg in. So we didn't need to know any of that information. So I think that was the most awkward thing in this question, is find out what you actually needed to use to get the answer.